Hey everybody, so tonight we're going to start talking about classes and objects, and this is the first step towards doing what we call object-oriented programming. In the past we were just declaring variables and assigning values. Those are aspects of programming languages that have been going back a long time, even to what we call procedural programming before the dawn of object-oriented. The reason is because those values and variables that we've been using are of what we call primitive types. So an integer is a primitive type, it's a single value. A string is a primitive type, it's a single value. And a bool is a primitive type, it's a single value. A double is a primitive type, it's a single value. So these are all primitive types, and they really don't have anything to do with objects, at least in our current understanding. So I'm going to introduce you to the concept of classes and objects in this first video, and we'll go from there. So I'm going to start off with the basics. I usually start off with the idea of a class. So I want you to notice that our program is empty, so I'm going to put like a comment in here that says do nothing. So our program does nothing. So what I'm going to do is, up until now we've only had one file, program.cs. So now we're going to go down the rabbit hole a little bit, and we're going to highlight the project, not the solution, but the project, and I'm going to say add class. So this is important. You're going to be doing this a lot, so don't forget, right click on the project, add class. So when you do this, you don't really have to do anything except type in the name of the class, and you don't have to put .cs at the end. That'll be automatic. The important thing, though, is make sure that it starts with a capital letter and the rest of the letters are lowercase unless it's multiple words. In this case, we're gonna call this first class person. This is usually the class that I start off with. What this means is that we intend to create people in our program. So if anytime you intend to create certain things, certain objects, you need to create a class. So if I intend to create people in my piece of software, then I need a class called person. So, make sure you name it properly. It should start with a capital letter, and it shouldn't, the name of the class shouldn't be plural. It shouldn't be, it needs to be like the abstract form of a type of object. For example, if I was planning on putting a bunch of buildings in my program, then I would name the class building, singular. If I was planning on putting a bunch of student records in here, I would call it student record, each word starting with a capital letter. So I'm just going to type in person and hit enter, and that will be all I have to do. So you'll notice that now I have two files. I have program.cs, which is what we started with, but now I have a new file, person.cs, and this is my class. So first I'm going to destroy the using statements just to simplify this. So let me talk about a couple of little details here. First of all, pay attention. In the IDE you have the little tabs up here, so you can switch back and forth between the two files that you're looking at. And over here, again, you can use the Solution Explorer to navigate back and forth between your two files. And for now, you want to think of this class, this other file, person.cs, as really having nothing to do with your main program, because at this point it doesn't. So think of it as kind of like we've stepped away from our main program for a minute, and now we're just going to create some ideas over here that we will use later. So when people are describing what a class is, they usually use the word blueprint. The reason is because there's kind of an analogy in real life. Maybe somebody is designing something that's going to be mass-produced, like a building, for example. Perhaps McDonald's is planning on creating several hundred buildings that all look and behave and have all the same aspects to it. So they need a single blueprint. They have one architect who comes up with a blueprint, and from that blueprint they follow the rules in the blueprint to go out and create all the different hundreds of buildings. So the idea is it's a one-to-many ratio. You have one plan or map or blueprint or whatever word you want to use, and from that blueprint you go forth and create as many instances, and that's a word that we use in software development, instances of the class as you want. So actually at this point we don't even have to do anything. Just the existence of this class allows us to create instances of a person. So what that means is, well, what does it mean to create something? Well, it's the same as declaring a variable. So whereas before we were declaring variables of primitive types like integer and string and bool, now we can declare a variable of type person. So I'm going to come over here and I'm going to declare a variable. Instead of saying int x or bool b, I'm going to say person p. So again, I can name the variable anything I want. I can call it, Donnie, or I can call it some person. It really doesn't matter. So I've declared a variable here. Now the confusing part is when we declare int x, that's pretty clear to us as to what that means. We think to ourselves, oh, well, there's some information that goes in this spot in memory. What type of information is it? It's a number. So we could think to ourselves, whoa, that's pretty easy to understand. We'll just, whenever anybody says, hey, I need the value of x, x really represents this location in memory, right? It's a memory address, and all we'll have to do to find out what's currently the value of x, we'll just go to that memory location and look at the bytes that are there and see what number is there, and that number really is going to be the value of x. It gets a little more complicated with a string, but not really. So if there's a string in memory, it still will go to that location in memory. It'll find some bytes there. The only difference is, instead of treating those bytes like a number, we have to go through some decoding process, either ASCII or Unicode, to come up with what string those bytes actually mean. But these two are not so different, because as soon as we follow the variable, we find the value immediately. So you follow the variable, which is just a location in memory, and you find the value. However, when you declare a variable of type of a class type that you've defined, it's a little bit more complicated than that. So basically this is the address of a person. It's still a number technically behind the scenes. It is a memory address, but what you find in that memory address is not a single value like it would be with an integer. It's not going to be a 10 or a 25. What it's going to be is you're going to find an address. So a lot of times we call this, I'll just put some comments in here for a second, the value of an object is an address. Sometimes we call it a reference. Sometimes we call it a pointer. And either way, all these kind of mean the same thing. It means this is basically a variable that will take you to an instance of a person. So it starts off as what we call null, because just like you declare a string and you don't give it a value, it's null. There's nothing in there. Well, I've done the same thing here. I've declared a variable of type person, and I haven't given it a value. So this is there's one small thing that I kind of need to hand wave at the beginning, and that's the process of actually creating an instance of an object. So I'm going to go ahead and do that. Some person equals. So obviously we're using the assignment operator, and the value on the right needs to be the same type as the value on the left. And as we can see from the variable declaration, the type of some person is person. Now, we don't have any other variable of type person that we can assign to that, and there's no such thing as a literal person, so we only really have one choice here, and that's to create a new person object. And the way you do that is with the keyword new. So this whole new person left parentheses, right parentheses, I want you to, at least for the time being, just kind of ignore the details of what those three pieces mean and just memorize it for now. Actually, I think maybe even in the next couple of videos, for this section I might go into it, but for the moment, just take my word for it that the word new combined with the name of the class combined with two parentheses will actually physically create a new object. And to shorten this down to our compound statement, there we have it. So instead of simply saying I'm declaring a variable and I'm giving it a type of person, which means it's an address of a person, what this does is it creates a new object of type person and gives back the address of that person. So what ends up happening is we end up with an object, and, well, the variable is actually an address of an object, and this object that we've created, its location in memory is now known by the variable somePerson. So just to show you what I'm talking about, if we put a debug statement right there on line 8, and we debug through this, so in my locals, notice it says somePerson is null because it hasn't executed this line of code yet. It hasn't created the new person, and it hasn't taken that object and given the address to our variable. However, if I step over that, now you'll see it has this weird looking example1 classes and objects it has this weird looking value inside of it. So this variable has a value now. If I hover over it, see it says that weird thing. So the point from this line of code so far that I want you to understand is that this declares a variable of type person, and this is a non-primitive variable, which means the value over here is not a number or a string. It's the address of a complicated object. So this creates a complicated object and returns the address. So it's still a number, but it's the number of a memory address, so it doesn't really tell you anything. The analogy I usually give people is, if I say, well, what's the value of Donnie's height? Well, you can say, how many centimeters tall I am. That's a value. If you say, what's the value of Donnie's hair color, right? You can say red. That's a string, and that's a single value. But if you ask somebody, what's the value of Donnie, I don't really have a single value. I'm complicated. There's tons of information about me. The best thing you can do is say, well, if you want to know the value of Donnie, I'll just give you his home address, and you can go and look at him yourself. This is the same exact concept. So by creating an object, a complicated object that consists of a bunch of information inside, it ends up giving us nothing but the address. So this variable has no knowledge other than the location of the object, and if you want to go inside of the object and find out what's in it, you have to do more work than just go to it. You have to go to the object and say, okay, now that I found you, tell me more about yourself. So up until this point, we've said that basically in our class definition, this is the blueprint for all people. So everything we put in here, all people will have. So the first thing I want to show you about putting things in your class is what we call, I guess I'll put a comment here, member variable declaration. Now we know how to do variable declaration, but this is member variable declaration. The reason we call it there's another, sometimes people call it instance variables. Instance variable declaration. So what we do is inside of our class, this is the beginning of class and this is the end of class. So everything in between these two begin and ends are what all people have. So just to reinforce that, class person, everything inside of here is the blueprint for all people. Anytime you create a person, this is what's supposed to happen. So if we do a simple variable declaration like string name, that says all people have a name, which is a string. If I do int age, that says all people have an age, which is an integer. So this should be really familiar because these are variable declarations. The only difference is, for now, and I'll explain this later, just go ahead and put the word public before your member variable declarations or instance variable declarations. The reason some people call these instance variable declarations is because every instance of person will have their very own name and their very own age. Okay? So remember, the class person is just a map or a blueprint for how our main program should react when we ask it to create a person. So if we say, hey, I want to declare a variable which is of a type person, now I'm creating a person object, it's going to say, okay, I'm going to go and I'm going to create an object, and inside of that object I'm going to put two variables that you can store values inside of. So now that we've done this, we can come back here and say, well, before this variable, this object wasn't so interesting, but now I know from my class definition, if I look back here and I say, oh, what is a person? A person is something with a name and an age. That means this guy, this variable, is a person, therefore this variable is a person with a name and an age. Now the way you, let me step back 1 second. I said before that the actual value of an object variable is a location. Just like if I said the value of Donnie is his home address, and if you want to know anything else, you're going to have to just go there and look. Same thing here. So if I want to do anything with some person, all I have right now is the address, and from there I have to basically do more work to say, well, okay, here now I am at the address of some person, but what do I do now? And what you use here is the period or the dot operator. The dot operator says, okay, I've arrived at the address of this object, now show me what's there. And this would be like, you arriving at somebody's house and saying, okay, I'm here at the address now, let me see what the different values of them are. So this is interesting because as soon as I hit dot, you can see the age and the name are both there, because all people have a name and all people have an age, because I said so in my class. So if you use the autocomplete there, someperson.name is just like any variable that we've used in the past. It has a declaration over here. It says every time you create a person, think of an object as an instance of a class, which is an object, as a ball of information. And this says inside every person object you have two variables. So this is just a variable. It just so happens to be inside of the somePerson object, and you can give it a value just like you can give any variable a value. We know that name is a string, so I'm going to give it a literal string. I'll just call this guy John. Call him John Doe. Oh, just John because there's just a name. I'll just call him John Doe. And I know from my class that every person has an age. And we'll say John Doe is 21. So this is our very first instance of the person class. So we haven't really done very much work here. We've created a class, and inside of here we have two variable declarations, two member variable declarations, or instance variable declarations, and we've said, okay, in English this says, first of all, this is my plan for what people objects are going to be. Every time I create a person, this is how I want you to create the object. I want you to make space inside of the person for a name, and I want you to make space inside of the person for an age. And because of this, the moment we come down here and we do this, the moment we create a new person, it actually behind the scenes says, okay, wait 1 second, you want a new person? Let me go into the class and see what I have to do. It says, oh, okay, a person is something with a string name and an int age. I guess I'll create an object with a string name and an int age, and then I'll give you back the address of it, so that this variable knows the address of that object. You can use that variable to go to that object and alter its variables, just like our variables before. The difference now is that all our variables before were just defined inside of the main program, and we call that locally defining a variable. The word local just means it resides in a certain scope. For example, this variable resides within the scope of the main program because we've declared it right here. However, these two variables are not in the scope of the main program. They live inside of the SomePerson object. So this, I know there's a lot of information to digest, but this is just the first step. So that's why I'm really kind of talking about it a lot. Normally I would just say this is a class, this is an object, this is how you create instances of the class, and that's it. But I'm trying to dig more into it. So remember, there's a one-to-many relationship. So I can create as many people as I want. So here's another person. So now I have another person, and just like before, I can set another person's name, and I can give them a different name, Jane Doe. And we'll say Jane is 19. So I could keep doing, oops, it's a string. So I could keep doing this all day. I can create as many people as I want. So let's step through this now and watch it actually doing something interesting now that I've made the person class have variables inside of it. So I'm going to hit F5, debug through this. Alright, so in my locals you can see some person is null, another person is null. That means that I've defined them to be able to point at a person, or have the address of a person, or have the reference of a person, or however you want to say it, but they currently do not have any value. They don't have the address of a person. They have nothing. So it's basically an empty value. But the moment I create this new person, now of course we see this weird thing here, which is actually just a weird notation for the address. And as before, where I said, you know, the value of Donnie doesn't make sense, but I can give you the address of Donnie, I can expand this variable SomePerson, and hey, look what's inside, an age and a name. And of course, they don't have values yet because I didn't execute lines 9 and 10 yet. So I'm going to F10 over line 9, and you can see it put the value of John Doe inside of SomePerson's name. And then I'm going to execute line 10, and it's going to put 21 into his age. And at this point, another person is still null because we didn't create it yet. Line 12 is going to create a different object. So now I'll go ahead and assign Jane Doe's name and Jane Doe's age. Program is done. I'm going to open up another person, and you can see all of our values. So if I collapse these, you can see we only have two local variables to the main program. We have SomePerson and another person. And each one of these, the values of those are just addresses of actual objects. We have two instances of person right now. We've created two people. And the way you can tell that deterministically is the amount of times you see the word new. So you see how we see the word new twice? That means that we've created two persons. If you see new person 5 times, then you have 5 new person objects. So we've created two people, here they are, and this is important. So some person's age and name is different than another person's age and name, because every time you create a new person, it's a new person. So just like with the McDonald's building analogy, even though you only have one blueprint or one class that kind of is an overarching rule for how every single instance is going to behave. In this case, the class says every person is the same in its nature. Every person has a name, which is a string, and an age, which is an integer. But that doesn't mean that every person has the same name, right? So everybody in our class has a name, and everybody in our class has an age. But we also have unique values for those names. We have our, well, maybe not unique, but we all have our own values for names and age. Same exact thing here. So this is supposed to be intuitive. You can create as many people as you want. They're all conforming to the data structure of how the class says they should. They all have names and ages, but they can all have different values. So that's the first lesson, really, is how to just create instances of an object based on a class, and from there really it just gets into more detail and more aspects of the language that you can leverage to make things happen. Let me see if I can throw in a couple more things that I want to clarify before I end this one. Let me stop this. I think I'll say one more thing about references, just to make sure that you're clear on this. So I have two person variables that are local in my main program. So what if I said to myself, I want person oldest person. Okay, so I've declared a variable. Now I want to assign it a value, oldest person. Now you might think I'm going to do this, but I'm not. In this case, even though I've declared a third variable of type person, I don't want to create a new person. I want oldest person to point to one of the objects I already have. I've already created two person objects. There's one, there's another. This variable points at the first one I created, this variable points at the second one I created. Now remember, when I'm using the assignment operator, the variable on the right has to be the same type as the variable on the left. So I have to basically point it at a person. I have two choices. I can point it at some person, or I can point it at another person. Well, the name of the variable kind of gives away that I kind of want to point at the first one, so I'm going to say some person. So this is just an important reinforcement of what we call objects, or I'll just say object references. I've already talked about this, but I'll say it again, kind of beating a dead horse, but every one of these variables that are not primitive are really just addresses of an object. So imagine this object lives at location 333, just some imaginary address. Then literally the value of some person is going to be 333, or whatever the address of this is. You can even think of it as, a home address. So when I say oldest person is given the value of some person, and I just told you that the value of some person is the address of this object, the first object that I created, then this right here is the address of the first object I created, and we're passing that value along to this new third variable. So the third variable is also going to have the value of the address of the first object I created. That's very important, because sometimes people get confused. They think that the number of variables and the number of objects is exactly the same. I haven't created a third object. I've simply given a third variable the same address of an already existing object. So this guy, some person, and this guy, oldest person, are now going to both point at the same object. So 3 variables, 2 objects. So let me kind of prove to you what I mean here. So I'm not going to execute line 16 yet, but I'll just jump to it to get back to where we were before. So I've got John Doe and Jane Doe. Now all I'm going to do with line 16 is set oldest person to the same value of some person. So they're going to get the same address. They're going to be pointing to the same object. And now I've done that, and if I expand oldest person, we see oldest person's age is 21 and oldest person's name is John Doe. And this is the key. I do not have a third object with the value, with the name of John Doe and the age of 21. Oldest person and some person are literally just variables that are pointing to the same exact object in memory. So I only have 2 objects. Remember I told you before, if you want to know how many objects you have, count the news. 1 new, 1 new. There's no new going on here. It's just pointing to something that already exists. So you've got to think of these object variables as pointers, references, addresses, whatever is the most fun word for you. And that is really the big leap you have to take in object-oriented programming, because we go from declaring primitive variables with simple values to objects, which are instances of a class. So, there's two hurdles to jump over here. The first hurdle is understanding that there's this code over here in our class that's just sitting there. It's not actually doing anything until this happens. The moment somebody says, hey, I need a new person, only then will it jump over here to the person class and say, hey, somebody just asked to create a person. What does that mean? Well, I guess it means I need an object with a string and an int. So the class isn't actually used until somebody attempts to instantiate an object of that class. That's the first hurdle to climb, which is the easier one. The harder one is to understand that the values of these variables are references. They're addresses of objects. So we declare the variable, which is a complex object. We instantiate, that's the technical term for create. We instantiate a new object. This variable gets the address of that object, and now we have free reign to manipulate all of the aspects of that. And in addition to creating new objects, we can also declare variables that point at already existing objects. One more thing. So in the past, every time, like in C++, for example, every time we created new memory, every time we created a new object, if we wanted to destroy that object, we would have to do that manually. Nowadays, we have what we call, I'll just type this, managed languages. So managed languages are languages that have a garbage collector. I'll write that down too, garbage collector. And this is just kind of like fun facts at this point. You probably get away with not knowing this for now, but basically at this point I have two objects. This first object I created has two variables pointing at it, that variable and that variable. This second object I created only has one variable pointing at it. So if I did this, what I'm doing here is I'm doing what is called dereferencing this object, because this variable was the only thing that knew about the address of this object. Now that I've said, you know what, I want to give other person nothing, so now it has no address. Now this object here, nobody knows who its address is. There's no more variables that know its address. That means there's no references to it, there's no pointers to it, there's no variables that have its address. That's what's called a completely dereferenced object. And the garbage collector is kind of this thing that's always running looking for dereferenced objects. So it will actually find this object in that case and just eat it up and destroy it. This object, however, has two things pointing at it. So even if I said some person equals null, that would not destroy it, because this variable here is still pointing to it. So this variable here would still be pointing to it. That means we still have at least one reference to it. Before, this had two references to it. By pointing some person away from it, then we're removing one of the two references, and it's still there because it only has one reference now. It has to get down to 0 references to be totally destroyed by the garbage collector. So if we did this, finally, these two statements combined would completely dereference that first object that I instantiated, and at that point that object would be destroyed too. So after these 3 lines of code, I could completely destroy those 2 people that I created. So, we're not really doing that in this assignment, but I just thought I would throw it in there since we're talking about object references. So, this might be, the one video that is hard to wrap your brain around, because getting into object-oriented programming for the first time is a little hard, but hopefully if you watch this a few times and mess around with it a little bit, it'll start to make sense. Remember, the key is just create a class, put some variables in it, and then instantiate some objects and try to utilize those variables. So at this point, it's been like 35 minutes, so I'll just leave it at that, and I'll move on to some of the next concepts in the second video.